Let me get that started here. So I apologize for getting started on the video late. We haven't gotten past the first screen yet, so if you need to hit pause and write some things down, do that. But we're just talking our way through the formula for the difference in two proportions, okay? And again, remembering that if we include z, okay, this is my margin of error. If all we're talking about is this from here to here, this is my standard error. So again, if understanding different vocabulary for that. Okay, so with the standard error, there is no z. All right, so there's the pieces parts to what we're going to work with, and away we go. Trying to do example 5. Now, this is a confidence interval, so my confidence interval still will follow panic if that acronym is useful to you. Again, I am not going to grade you against using panic. However, I will grade you against all the parts that are in panic, so it's 6 of one, half a dozen of the other. It just needs to be there, however you want to get it there. As part of a Pew Project of American Life, as Pew Internet and American Life Project, researchers conducted 2 surveys in late 2017. The first survey asked a random sample of 800 U.S. teens about their use of social media and the internet. A second survey posed similar questions to a random sample of 2,253 adults. In these 2 studies, 87%. All right, so again, I'm not doing a very good job of doing this. My pen turned off. We had a random sample of U.S. adults. We had a random sample of U.S. teens. Okay. And again, it doesn't matter. We can start writing this stuff out as far as, I'm going to say that T equals teens, and A is standing for adults. And so I'm going to have an N for T being 800. I'm going to have an N for adults rolling in at 2253. In these 2 studies, 87% of teens, so that means that my P hat for teens is going to be 87. My P hat for adults rolls in at 63. Said that there's a use of social networking sites. Use the results to construct and interpret a 95% confidence. So if I want to be 95% confident, again, this is going back to your z-score, understanding you either need to be able to know how to find that z-score or memorize. So 95% is going to be a 1.96 is what we use for a critical value there. For the difference between the proportions of U.S. teens. So again, we're estimating the difference between an adult, how adults respond to the survey, and teens respond to the survey. Okay. So if we go through panic, we've listed out all of our sample proportions or our sample statistics. Our parameter of interest is going to be the difference in proportions of social networking between teens and adults. Okay. A, again, stands for my assumptions. So whenever we do any type of inference, we're going to have to make sure our assumptions are met. So number 1, random sample. of US teens and adults. If I could spell adults. Number 2. This is approximately normal. And how do we know it's approximately normal? Well, that means we have to do 87 times 800. And is that greater than or equal to 10? We're going to take its complement, which is 13 times 800. Again, our successes and failures of each group have to be greater than 10. So I can see that US teens, we're good there. If we switch to the adults, 63% of the adults, there was 2,253. So this is evidence that my sample size is sufficiently large. And our last one is going to be independent. We're good on independent because 800 is less than 10% of all teens. 2253 is less than 10% of all adults. And we have matriculated our way through the assumptions. Okay. Naming of the test. So this is going to be a 2 proportion. Since I have the difference, now we're talking about a 2 proportion. Z interval. And now we're going to use that equation that was on the other page. So we have the difference of basically teen minus adults is what we're finding. Did it tell us to use a specific direction? I mean, that's what we need to look for, make sure that it didn't just specifically say. But I did it. So my interval could actually, there's 2 acceptable intervals a lot of times, just depending on which way you subtracted. So there's the difference in our point estimates, plus or minus. My critical value is 1.96, and then my standard deviation or standard error okay. And now this becomes the great calculator pain in the butt, because that's a lot of keystrokes to enter. A lot of times we can get an error message to come up, or we're going to miscalculate because we did something wrong. I'm going to go ahead and write this in there. Not that I expect you to find that, but that's what it turns out to be. And we get an interval that goes from 0.209 over to 0.271. So here is where we're going to kind of move away. I shouldn't say move away. On the test today, or on the test for this unit, and on all my tests, I am going to expect that you give me that. In reality, it says my internet stable connection is unstable. Well, hopefully you can still hear me. Anyway, in reality, we just need a name and then we need an interval, because our calculator can do this for us and it's okay. However, I want to see, I think this helps us understand conceptually what we're doing. So I'm going to then request this be on your test, even though AP does not have that requirement. So here we go. Let's go out to our calculator. Out to our calculator, wherever my calculator is at. Okay. So we are in our calculator. Over on the left-hand side, nope, excuse me, we're going to go into stats. So we're going to hit our stats button. And I'll slow down because I didn't give you a warning ahead of time that you're going to need a calculator today. But if you look up at the top, you have your 3 menus of edit, calc, and test. We're going to go over to tests. And we see that we have a Z test, we have a T test, a 2-sample T, a 2-sample Z, a 1 proportion Z test, and a 2 proportion Z test, and those are all tests. However, if you scroll down, if we scroll down, we see that we have a Z interval, which we would have which is based upon, again, a mean. If we scroll down even further, we get to a 1 prop Z interval, which was what we would use on yesterday's material. If we arrow down one more time, we get to a 2 prop Z interval. And again, because I'm using a different brand style of calculator, yours might not be in that order. And I'm not for sure if it even uses the same naming nomenclature. However, look for a 2 prop Z interval because that's what we're constructing. So when we select that, okay, it is again going to ask us for the information. Okay, how x1. Okay, so this is let me grab my where's my TI-84 at? This looks different, and I forgot to look at it ahead of time. Shame on me. I thought it would ask you for the proportion for your p hat instead of x and n, but maybe I'm wrong. Wouldn't be the first time. Nope, same thing on a TI. Somebody could have spoken up, saved me some time. It's all right. All right, so we need to know what x and n are. This becomes where it's a little bit wacky as far as we can try it and plug that in there. But we know that 87%. So it's not going to be a percent. We're going to take 0.87 times 800. Now, what happens if we do that? Can we just see? Oh, gosh, that's my fault. We had 800. I know I'm going to get an error message here, but I was just trying it. I'm pretty sure we have to enter solid numbers there. And how confident we're going to be? 95. We're good there. All right. No, it took it. Sure enough. Look at that. Okay. So there we go. Again, and so that means that never will I ask you to actually calculate an interval. Okay. As far as expecting you push yourself through that and getting all that typed into your calculator. But my calculator will create the interval for me. So if we look there, that's where we get the 0.209 to the 0.271. So again, my calculator is going to be spitting out all this stuff for me. Okay, so if we come back to this, we have named the interval, we have found the interval, and now we have a conclusion to make. We are 95% confident the true difference in the proportion of U.S. teens and adults using social networking sites lies between 0.209 and 0.271. And so that part remains the same. So the mechanics of what we're doing remain the same from what we did 2 days ago to what we're doing today. Is still the same exact stuff is in there. Okay. The only difference is we have to do a little bit different here with the assumptions as far as we have to get both groups included. And then my equation is going to change just a little bit out here. For that, but stating my conclusion and doing all the other fun stuff, that all remains the same. So there we go. I mean, that's it. That's our difference in the difference between a 1 sample and a 2 sample. Okay. For some reason, that is not scrolling. I don't know why. I have, there it is. Okay, a little slow. All right, here we go. Last example, and then we'll break out and go look at your test. The mentor is interested in Mrs. Sapp's approval rating. According to a mentor poll of 63 recently selected students, randomly selected. So again, we'll highlight that as we go. We had randomly selected students. In May of 2018, a 50% approved of Mrs. Sapp's teaching methods. A mentor survey of 55 students in May 2019 showed that 53% approved Mrs. Sapp's teaching methods. So sorry, I just reading through this. I should put another word in here because right now we don't know that the May 2019 was randomly selected because it doesn't say anything about it. Okay, and that'd be one of those details that it's probably bad, me and having the equation, having the created the problem, and I just missed that detail on the AP exam. And they're not going to give you one as a randomly selected, and another one's not going to be randomly selected, and then they're going to catch you on the missing that. But anyway, 2019 showed that 53% are approved. Is there evidence that Mrs. Sapp's approval rating changed between May of 2018 and May of 2019? Okay, so again, we'll just go through here and we'll write down, again, it is however you want to use Panic. I just like to write down everything that we have. So we have a P hat from 2018, and that was a 0.5. And the N from 2018 was 63. I'm not for sure. Must have had some rounding going on. I'm not for sure. Must have. I don't know. We also have a P hat from 2019 coming in at 0.53. My N for 2019 is a 55. Okay, now here's the other thing that's unique to this problem that we haven't come across yet. It says, is there evidence? Okay, so this is actually, we can do this problem a couple of different ways, but since we're working with intervals right now, we'll do it with an interval. And the problem with the interval right now is they did not give us a level of confidence. Okay, so just as a side note up here somewhere, okay, if no confidence level, ugh, can't type and speak at the same time. If no confidence level is given, we default to 95% confident. So that means that we're going to use a Z of 1.96. Okay. The parameter of interest, again, and this one's a little bit different as far as, again, they're asking us for evidence. They didn't say create an interval. So, excuse me. Therefore, the parameter thing is going to be a little bit off here, but we're going to go ahead and check that because we're not actually finding the difference between the two. Okay. However, this is going to be an inference method, so we're going to have to do our assumptions. 1 is going to be a random sample of Mrs. Sapp's students. We could flag this as far as, hey, 2018, it showed a random sample. 2019 did not say random sample. And then, but we could proceed. Typically what happens, then we just proceed with caution. I'm not going to do that right now. Okay. Number 2 is approximately normal. So we have to take 0.5 times 63 to be greater than or equal to 10. And the odd part is we have to show both successes and failures. It has no idea which one's which, but you have to still show both groups. The other thing that's unique here is, well, here, no, we'll get to that in a second. Three, lastly, is independent. So then this problematic has problems written all over it. 63 is less than 10% of n. So let's talk about that. Think about that statement for a second. That would mean that Mrs. Sapp would have to have 630 students. Now, we have no idea if that's false. However, if we know anything about school, you know that that's not going to be the case. Same way with 55. So we're going to put a little asterisk here, and we're just going to say proceed with caution. Because we can't guarantee that's true. So again, we have two proportions. So if we're going through we've done our assumptions, we need to name this guy. This is a two proportion Z interval. We have 53 minus 50 plus or minus 1.96. We have 53 and 47 divided by 63. We have 0.5 and 0.5 divided by, whoops, that's the 63, no. This other one should be, and I don't know why I went in the reverse order. I don't know why I did 2019 first, and I ran it because we're adding it together. It's actually irrelevant, but this one should have been 55. So this turned out to be 0.03 plus or minus 0.181. However, I would never expect you to do that. We're going to run out to our calculator. We're going to go stats, tests. I'm going to arrow up because it's faster. There's my two proportion Z interval that I'm going to create. I'm going to clear that out. And we have, okay, according to the way I set mine up, we did 53 minus 50, which means we're doing 2019 minus 2018. So I suppose I need to keep it in that order, but we'll talk about why it really wasn't no matter in the end. We have 53 times 55. And then this is going to be a 55. What up? No, I am, but it doesn't matter. This is from whom? Main office? Yes. Okay, then. You too. No, you can leave it open. I'm good. We're gonna clear that out. We're gonna have what's next? Lost my train of thought. Oh, 0.5 now. 0.5 times 63. And then we're going to arrow down and we're going to get 63. We're going to remain at 95% confidence, so that's okay. We're going to calculate that, and there it is. My interval goes from a negative 151 to a 0.211. Now, just as a note over here, if we had gone with 0.50 minus 0.53, if we had done that instead, then my interval becomes a negative 0.211 to a positive 0.151. And I wrote that wrong. 0.151. So that would be my interval if we went the other way. But here's what we're again, we're going back to the question that was asked us. Is there evidence? Okay. And because is there evidence of a change? Okay, and because 0 lies within my interval, no, there is not evidence. No, because 0 is in the interval, making no change a possible answer. Suppose a follow-up survey was done in December of 2019. The mentor reported that 64% of students approved of Mrs. Sapp's ratings. The mentor concluded that there was a significant change in approval rating between May of 2018 and that should be December of 2019. Comment on this claim. So we have all the stuff from the previous problem. We just need to know the p hat from December of 2019 is going to give us a 0.64. So if we go ahead and create that interval, how many was in this sample? Huh. I don't see where it told me. So here we go. We're gonna okay. So this is again n equals 50. We're just gonna write that in there. That didn't give me a sample size, so we were kind of out of luck. But there we go. This is the interval that we were doing. So to cut to the chase a little bit, I'm going to go with a negative 0.0415 and a 0.3. There's no sense in watching me put this into the calculator when that's all I'm going to do is write it down afterwards. Now, the question is, we are supposed to comment on this claim. The mentor concluded that there was a significant change in approval rating, and our answer will be does not support claim. Because 0, no change, is still in the interval. All right. That actually took way longer than I thought it was going to take. So here we go. I'm going to stop recording.